Just sharing my screen. We'll get started in a little bit. Hi, Julia. No problem. Happy to have you here, and it's all good. Hey, Tanya, how are you?
Hi, Bill. I'm well. How are you?
I'm good.
You doing okay?
What a day, huh?
How was your day?
Busy but good. How
Good.
about yours?
Same, busy. Oh, and I have some news. I asked the HPLC tech from Agilent because I know you were curious about a caffeine experiment. So I asked them like what they do for theirs, and he told me a lot of information, just even about the method, which is great, where to get standards, all of that stuff.
That's awesome. Thank you.
No, you're welcome. Yeah, I was thinking of you, and I'm like, oh, let me figure out how to do this because I have that other experiment, but since he does it all the time.
Hey, and Tanya, are you okay with me doing the intro, you doing your part, and then me doing my part? And then there's only one slide afterwards. So,
Yeah, that would be great. And then I was wondering because with the 484, I saw you had your name only. Is it okay if I tell some of the students that I'm accepting just a few students for that?
yeah. So, meaning that you were going to have students. So, what? Yeah, tell me what that means, though.
Yeah, they'll be in your 484 like usual, and then they'll work with me because I think
Oh, of course. Yeah. No, it's just what we always do, right?
yeah.
Perfect.
Because I
Yep.
think a couple of them are coming and I don't want them to be confused.
Yes, whenever you need to, just or whenever you want to, just point that out.
Okay.
Hello, everyone. Hi.
Hi,
Hi,
Sheree.
Sheree. How are you, Sheree?
Thank you so much.
Glad you're here. Oop. Just trying to tile all these windows here. What my favorite PowerPoint secret is?
What?
It's that I can get I can get my PowerPoint, and probably everybody knows this, but I can get my PowerPoint just on a part of my screen. Instead of taking the whole screen, so I can still see everybody on the list of videos and get the chat up there too. So
Yeah, no, that's good. When it comes to I have the video in one of my slides.
mhm.
Do you see I put the new link in there on the one that I updated before? Do you see that place to push play?
This one?
Yeah. Because I noticed when I was having it as a,
Sutter?
Yes, it opened in a new window.
okay, that's the only thing I was kind of worried about.
Let me stop sharing for a minute. Let me see if I can take care of that.
Are you looking for a well-paid career in technology? Does working in a lab
It
environment
won't let me
cannabis,
download
food,
it. Oh, so what I'll do is I'll keep it in another window and I'll switch
looking
sharing.
for a
Well, I'll switch sharing for a minute if does that work?
Yeah, I think that should work.
All right.
Thank you.
You might have to remind me though.
And no worries, that's the only thing I was thinking of, because for some reason on this, it doesn't let you push play, but if it was like a PowerPoint, for some reason it let me push play. I don't know why.
Oh, let's go back to the beginning. There we go. Oop, stop sharing for me. I'm just gonna cut and paste the link to the Google sign-in sheet.
Oh, okay.
Almost. Oh yeah, it's good. For those of you who are here and would like potentially extra credit from your professor, actually, I don't know if that works. It did not. Let me try again. And perhaps we'll get started in just a minute or two. Hmm. Oh, I think that'll work now. Although one of them will anyway. Ah, okay. Sorry, I'm just getting better at doing the link. All
I
right.
don't even know how to do that.
Neither did I at the time.
That's
And
cute
then
pictures, too.
I'll post it a couple more times too. Each time this gets a little better, Tanya, right?
Yep, and I love your pictures. I was looking around for some pictures of what I have, and I couldn't find them at like really on time, so I just put the AI generated cannabis thing on there.
That's awesome. Well, so Tanya, what do you say we get started?
Yeah, let's get started.
I'll introduce myself, and I just want to say my name is Bill Miller, and I teach chemistry here at Sacramento City College. You want to introduce yourself, Tanya?
Yeah, I'm Tanya Atkins, and I also teach chemistry here at Sacramento City College.
And this is a presentation we've done once before this last fall, and second time now, about introduction to research opportunities at Sacramento City College. And we've got some pictures of our some researchers. We've got some data, some also pictures of some lovely cannabis there, which will be analyzed. Now, what undergraduate research opportunities exist at Sac City? We are blessed as a community college to have many. And I'm going to be talking tonight about the undergraduate research lab classes, Chem 484, Chem 405, and Chem 406. We've got their names right there. I'm going to go ahead and just let you know that these are all offered simultaneously. And what we ask is that if you're in your first semester doing research here at City College, that you sign up for Chem 484. If you're in your second semester, you sign up for 405. If you're in your third semester, you sign up for 406. And either in the morning or in the afternoon, you can sign up for any of those three classes based on where you are in your undergraduate research career here at City. Tanya, you teach the Chem 429 research in chemistry. That's going to be on Friday afternoons like it traditionally is, right?
Yes, yes. And I'm also going to take a few students along with Bill with the 484. So if you're interested in that, just the first semester after this presentation, just let me know and we can talk offline and give you my
Yes.
contact info.
And I think that's one of the take-home messages for Tanya and I. First of all, we love working together. Second of all, if you're interested in doing research and you just talk to us and we'll tell you you can do it now, you can do it in a semester or two. And if you don't quite fit exactly what we're talking about, please get in touch.
Yes, yeah.
There are also undergraduate research parts of some of the lab classes here at Sac City. Chem 410, quantitative analysis, taught by Jerry Ochoa. That's going to be offered spring only each year. And in spring 25, it's Tuesday, Thursday, that's both days, 4:30 to 9:20 p.m. It's a great class, very quantitative, very lots of numbers, which Tanya and I, we both love numbers. We both love a good spreadsheet. So does Jerry Ochoa.
Yeah.
And then if you take Chemistry 400, if you have taken it, there's a undergraduate research experience in that course, a relatively short one, because we get undergraduate research experience everywhere we can. If you're asking yourself, why do undergraduate research? Well, it's a great experience in solving problems and learning new skills. And for me, amongst all these other options, it's really what science is all about. I love teaching Chem 400 and Chem 401 when I can, but they're both sort of teaching you about topics that, and you're doing labs that other people have done before. You learn a lot of skills, but not a lot of new skills. Or let's say this, they're new to you, but you're solving problems that others have solved before. And in undergraduate research, you're creating new data, you're solving new problems. And as it says, it's a great resume item, great part of a recommendation. It can lead to something called an REU, which is a research experience for undergraduates. I'll talk about that for one or two slides coming up next. And lots of reasons to do undergraduate research. What is a research experience for undergraduates? Well, that is when you go to a different four-year school usually. You do 8 to 12 weeks of full-time research over the summer. They generally pay between $5,000 and $8,000. And if they make you move across country, they oftentimes have a stipend just to pay for you flying out there or driving out, however you do it. There are lots of programs. There's one even at Queensborough Community College in New York. There's one at California State University, San Marcos. I've chosen these out of the hundreds of different programs because they are interested specifically in community college students. And because these are funded through the National Science Foundation, they are only open to US citizens and US permanent residents. But there are lots of areas you can do them in, of course, chemistry, biological sciences, STEM education, all kinds of areas. And what we like to do is we like to set up students, give them the experience of doing undergraduate research, and then prep them so that when they transfer to a four-year school or when they go to an REU, they have a much stronger application, a much better chance of doing higher level research. What is expected of you for undergraduate research? Well, safety first, of course, but then in general, you'll read scientific articles. With your research advisor, you'll formulate and conduct new experiments. And a lot of the process, especially in my class, is, and of which I imagine it's also in Tanya's, is you have to learn the techniques with known samples. And then you go on, once you've got your technique down, to do new experiments. Class time required for the Chem 484, 405, 406, and Chem T 429, 3 hours of lab time per week for the whole semester. And of course, for the courses, it depends on how much they integrated into the course. I'm going to turn it over to you, Tanya.
All right, thank you. I want to talk about a couple different things, but first I want to advertise our chemical technology certificate program, our ChemTech program. And with the ChemTech program, I'll talk about that first and then the undergraduate research. So we have 3 certificates. So Bill, can you go to the next page? I think it's the video. Yeah. So we have 3 certificates, and this is a little bit of a dated video. We're working on a new one right now, but it still gives the message across about how the program works. So can we play that video?
Yep.
Thank you.
Can you see it? Can you
Yep,
see
I
the
can see it. Yeah.
You looking for a well-paid career in technology? Does working in a lab environment in the cannabis, food and beverage,
Can you hear it?
I could hear it. It stopped though now.
Okay.
forensic, or environmental industries interest you? If so, the Sacramento City College Chemical Technology program is for you. Whether you are finishing high school, are a recent high school graduate, or want to change careers, Sacramento City College's ChemTech program is the fastest, easiest, and one of the most affordable ways to begin your career as a chemical technician, requiring some post-high school training, but less training than a university degree. The ChemTech program has 3 different certification levels to offer. A level 1 beginning chemical technician certificate can be earned with only 1 year of training, allowing eligibility to work as an entry-level laboratory technician. You can earn a level 2 certificate to become an intermediate chemical technician after a year and a summer of training, which provides eligibility to work as a laboratory technician. A level 3 advanced chemical technician certificate can be earned after 2 years of training, which affords career opportunities as a winery analysis technician, chemical plant technician, forensic science technician, and much more. Besides providing hands-on learning and an opportunity to work with modern equipment in a supportive school culture, we also help connect you with employers in various industries through internships. If you have already taken some chemistry courses, you may already qualify for our level 1 certificate. If this is the case, please get in touch with one of our coordinators listed on our website. Please be sure to check out our brochure. With a lab technician's average salary of $48,000 a year, space is limited. So please visit our website today.
Thank you, Bill. And so I just wanted to talk a little bit about this program because it seems like this program you would do separately, but a lot of times students will do this while they are being preparing to transfer to a four-year. And what's nice about this is, like the video said, you may have a lot of these classes, so you may already have the courses needed to earn that certificate. And one more thing that this does is that a lot of the students who have participated already, it's been going on now for a couple of years. They end up with jobs in the stockroom. I just had a student who transferred to UC Davis and now got a lab job. And she's a student now at UC Davis, and she got a lab job with a PI over there. It's an entry-level position, but again, started with the program. We have another student, Kim, who's part of the program, and now she's, really is managing the stockroom for us at Sacramento City College. And also, some students would just like to get a job as a lab tech while they're going to school. So there's just a lot of opportunity there. And like I was saying before, you may have these classes already even to earn that first level certificate. And then there's opportunities for externships. So a lot of the work that I'll talk about, the research that I do, I base that upon our advisory board and what their interests are to kind of help guide our students for the ChemTech program. Plus, I was interested in it myself. Yeah, and the next slide.
Oh,
Is it like stuck?
hold on.
There
There we go.
Yeah, and so this is just some information from ACS, the American Chemical Society, about technical professionals. So there are 3.4 million unfilled skilled jobs expected by the end of 2022. Little dated still, but it's about the same. 1 in 9 jobs right now in STEM fields don't require a bachelor's degree. And as of 2021, there are about 336,000 chemical techs, chemtechs employed in chemical production. And if you are interested, here is some info. This is just a little pic of our website. I have the QR code there. You can go ahead and go there, and you can see here are the courses that are going to be offered in the spring. So we have ChemT 201. That is a fully online careers in chemical technology course given by Dr. Agnew here. It's a great course. You figure out, you find out what it's like to be a lab tech. Really, really informative course. There's no tests or anything, so that's what's nice too. And then you see here for ChemT 296, it's an internship opportunity. That's more for if you're beginning, and that's working in-house in our stockroom. ChemT 297, that is this is for the advanced certificate. So we already have students right now at UC Davis, the Sacramento Water Utility, working as externs. We also have an extern here on campus, the Sac City campus, to help out with courses. And then there's the ChemT 424 course, instrumentation course, and then the research course I'll talk about today. Thank you. And then again, here is the course list. So if you're interested, the course list is here. It's broken down, so Cert 1, 2, and 3, different pathways to get there. And I just want to point out the pathway 2 for Cert 3, it says 420 and 421. Really, all you need is 420 to be able to go ahead and do pathway 2. You can do that concurrently because most of you who take that will take the next one anyway. And even if you leave our campus to transfer, you can always come back after you've taken these courses and apply for the certificates too. So it's not like you have to do it while you're here. All right, so let's talk about the research project. So I'm going to talk about these quickly. If you're interested, please reach out to me. I'm very happy to talk about my research. I love doing research, but I have 2 main projects. I have cannabis analysis and also synthesizing CBD. I'm stepping my toe into that a little bit, and also water analysis. So why did I pick cannabis? So I picked cannabis for several reasons. It's interesting. There's a lot of chemistry to do, lots of instruments to use, but also really cannabis is using for like a broad application in medicine right now. There's a lot of research being done on it, and it's because as of February 2024, there's only 3 states and 1 territory that don't have legal cannabis programs. So there's a rapid growing demand for reliable and accurate analysis. So you want to inform consumers about what is in cannabis products if they're consuming this product. So for the production and safe, reliable cannabis, it requires, like I was saying, accurate analysis. But what are we analyzing? There's so many things to analyze. So again, I'll talk to you about that individually if you're interested, but I have lots of different projects analyzing lots of different things. Now we can go to the next one. So we use a lot of analytical chemistry. So we're very fortunate at Sac City. We have lots of instruments, and I'm very excited today. We're having a lot more new instruments. We have a new HPLC that was just installed today. We're getting what's called a new LCMS. If you don't know what these letters are, HPLC, high performance liquid chromatography, LCMS, liquid chromatography mass spectroscopy, and then others. But what's nice is we have these instruments where our sister schools don't have as many instruments as we have, and we now have brand new ones. So along with some old ones that we get to use. So the role of the analytical chemistry is we want to ensure consumer safety. We want to confirm that our products are free of contamination. And like what we do as well is we want to make sure that we can just analyze for cannabinoids or terpenes or whatever it is we're looking for. We want to optimize it as well. So I talk a lot about method development. So not only in my research group do you learn about extraction, some organic techniques, you also learn about optimizing methods. And that it sounds like it's I don't know if it's a small thing it may sound like, but that's a really huge thing to be able to optimize these methods. It's like a whole project.
Oh, yeah.
And again, cannabis is unique, over 500 compounds that are really not found in other plants or animals. So it's really exciting to be able to test it. It's hard to test it. That's what analytical labs struggle with. And we do this again because we, on our advisory board for Chemtech, we have a cannabis lab who does this. And they were saying it would be great to have more students who would want to work in that industry, know a little bit about analyzing cannabis. So as everyone knows now, there's lots of products, CBD, THC, there's chocolates, there's like beverages, right? They have beer now with, you know, THC and all of these things. So it's a really unique challenge to extract all these different types of materials and get the accurate analysis. So I think the next slide. Again, fastest growing industry, we're going to use lots of instruments to do it. And I don't want to say too much and take up too much time, but really, I think that's like the big picture of my project. Lots of different things to do, and looking for those contaminants. Yep. Water analysis, we are also affiliated with the Sacramento water utility, and we work with them, and they want us to help train students so that they can eventually be externs. Also, I have students who are just interested in water analysis. We have instrumentation for that as well. So it's really important to know what's in your water, what's in the city's water, and how you can do that. So we got new equipment for that too, and we can go to the next slide. We also we're getting a new AA as well. That's a picture of, it's called atomic absorption. There's a flame in there, and you can test for metals. So you'll learn how to do all of these things for all of my projects. By the end of the semester, I really try to make it so you work independently or predominantly independent, especially for the ChemT courses. Now, if you're in 484, I usually I pair you up and I teach you a lot of these skills first. And then as you go on in your career, your academic career, then of course you'll start to become independent as you go on. All right, thank you.
Yes, great work, Tanya. Thank you. All right, I'm going to talk about my two projects for spring. Project number one is molecular modeling, and it's a collaboration with Professor Osvaldo Gutierrez's group at UCLA. And that's going to be Friday mornings. And I'll give you the times again, but it's roughly 8:30 to 11:45 on Friday mornings. And again, and my classes, the Friday mornings and Friday afternoons are at the SCC Davis Center. In fact, I forget if I mentioned this before, but you can take both of them if you'd like. But yeah, so the molecular modeling, that's one of the projects I'm going to talk about today. And the second project is estimating the partial molar volumes of each component in a binary non-ideal solution. And one of the things, so I am splitting the projects, molecular modeling in the morning and wet lab work in the afternoon. So Osvaldo Gutierrez, his group does molecular modeling. He does a lot more than that, actually. But I'll just go over a little background about what he does. He takes what is known about an organic chemistry reaction that is catalyzed by an organometallic catalyst, So that is metals bonded to organic molecules as well, sometimes called ligands in Chemistry 401. And he tries to figure out new ways to do the reaction that will be less expensive and or lead to higher percent yields and or new reactions. And how he does this is he actually does wet chemistry as well, but the part we're going to focus on is the computer modeling to determine the energies of the reactant and the catalyst when bonded together. And when a reactant is interacting with a catalyst, that reactant is called a substrate, and that's the term I'll be using for the next few slides. And then lastly, we won't talk about it, but he is particularly interested in using iron catalysts because there's not a lot of work being done on them, and that's really one of the reasons he's pretty internationally known. And let's review a little bit about what it means when you take what's known about an organic chemistry reaction. So alkyne hydrogenation. An alkyne, as you may know, is any molecule that has a carbon-carbon triple bond. And hydrogenation means you're going to add two hydrogens to it. So if you look at this molecule, this generic molecule here, it's got two gray parts, and those could be other parts of molecules. And if you go down to the bottom here, you can see that if they're carbons, we've got the triple bond, and then each of those triply bonded carbons is single bonded to another carbon with hydrogens. This molecule with the triple bond up here could also have a pH group, and pH is not the power of hydrogen. It is phenol, and this is a lot of organic chemistry, which we get to at the very end of Chemistry 401, an introduction to. And we've got an alcohol group over here, which we do talk about even in Chem 400. But what happens is if you take an alkyne of almost any sort with two groups and you put a metal and ammonia, people know that you get a transalkene, where the two gray groups are opposite each other and the two hydrogens are opposite each other. And a transalkene example is right here. And it turns out that transalkenes are considerably more stable, or more stable enough that that's the easier thing to do. It is significantly harder to form a cis-alkene. You got to have what I would nicely call a whole bunch of stuff. And even then, it doesn't really work very well. And there are challenges and limitations to make this molecule, which is a cis-alkene. And so what Osvaldo's group wants to do is look at how this works and understand it and use molecular modeling to do that. And he has chosen a particular alkyne hydrogenation with this molecule right here, this redox mediator and the free catalyst. And so there's quite a bit of chemistry in here, but I think it does get a little simpler when we get to the part that we're going to attack. But I want you to keep your eyes on this molecule here, the cobalt, with different groups attached to it. And what we need to know right now is that if you use these catalysts under these conditions, you do get cis alkenes in some ratios, though I will point out it is very complicated. Well, now let's talk more about what we're going to do. So we're going to step in step 3 here to figure out new ways to do the reaction. Osvaldo's group uses computer modeling to determine the energies of the reactants and related to the products and the catalysts. And so his group has asked the question, alkyne hydrogenation, if after you do this, is it possible to reduce the alkene product? And reduce here just is similar to what you might have heard in Chemistry 400 or Chemistry 401, except here it specifically means add 2 more hydrogens. And what we're going to do is we're going to model the energy of the catalyst and the alkyne versus the catalyst and the alkene. And that's a much simpler problem that we can tackle. And so I'm showing on the left here a catalyst. Here's our alkyne. they interact with each other in this shape right here. And this is what we would molecularly model. And this number right here means minus 8.5, that when the cobalt interacts with the alkyne triple bond, minus 8.5 compared to 0 of the initial separated parts, this is lower energy. Negative means lower energy. These two, when they interact, lower their energy. And this is the alkyne. This is the triple bond right here. Oh, did I mention I love units? These are kcals per mole. All right. Then, now we're going to have the alkene, both trans and cis, and we're going to look at what the energies of these two are apart versus interacting. And these positive numbers, 1.9 kilocalories per mole and 2.8 kilocalories per mole, are higher in energy. And what that means when we do our molecular modeling, or when Osvaldo's group has done it, we're going to attack similar problems, is positive numbers mean compared to the two separate molecules, the catalyst and the substrate, these two have higher energy. And so higher energy states, we talk about this in Chem 400 and Chem 401, higher energy states are unfavorable. Lower energy states are more favorable. And so that's one of the things they've learned doing molecular modeling. The triple bond reacts because it's lower in energy. The double bond, the alkene, doesn't react because it's higher in energy. And that's where we're going to come in. We're going to model similar systems. Osvaldo's group is going to come in and say, hey, we want to understand more about the energy of these two, of this molecule, this substrate and this catalyst. They're going to teach us how to model it, and then we're going to model it in collaboration with them. And so students who work on this project, again, it's recommended that you have completed Chemistry 400 and Chemistry 401 to be in this project. But you'll learn to model chemical system using computer molecular modeling. You'll learn how to quickly assess how changes to the nature of the substrate affect the energy and therefore the reactivity. And then by mapping several competing pathways, you'll be able to look at the energies of several different things, several different possible reactions. This is a new collaboration. I'm excited because I look forward to learning a lot about this project as well. So many cool things with this project. And this is new starting spring 25. We will be collaborating remotely with Osvaldo's graduate students down at UCLA. And Osvaldo is committed to promoting students from underrepresented groups and students from community colleges. He is a full professor as of January 1st, 2025 at UCLA with all of these lovely acronyms that are very cool. And last but not least, fun fact, Osvaldo is a former student of mine and Ling Wong's at Sac City College back at about 2004. And we've kept in touch, which is awesome. And
That's
Osvaldo Gutierrez, he is OG for sure. All right, so the next project, estimating the partial molar volumes of each component in a binary non-ideal solution. So what is a non-ideal solution? If you take 100 milliliters of 2-propanol and 100 milliliters of water, you get 192 milliliters of solution. That is non-ideal. Because ideally, of course, you would add 100 plus 100 and you would get exactly 200 milliliters. And I've got a bottle of hand sanitizer here that is basically 100, so 50% of 2-propanol and water. And that's sort of why I got into this, was during the pandemic, I wanted to understand a little bit more about solutions that were similar to hand sanitizers and what goes on with them. Well, next thing you need to know for this project is what is the molar volume. We're all more or less familiar with molar mass. Molar mass is grams per mole. Molar volume is milliliters per mole. So volume per mole, literally a molar volume. And the way that you can calculate it, Vm is molar volume. It's just the molar mass divided by the density. And you can see that water, pure water, has a molar volume of 18.07 milliliters per mole. 2-propanol, also called isopropanol, has a molar volume of 76.97 milliliters per mole. And these are, we're familiar with molar mass in Chem 400, 401. We're familiar with density. We're just taking the ratio of the two of them. Now, what is the partial molar volume? It is the molar volume of a substance when it is mixed with another substance. And in this example, we're taking a large amount of 2-propanol, color-coded green, and we're adding a mole of water to it. And it turns out that instead of 18.07 milliliters per mole, its partial molar volume, partial because it's mixed, is only 14.48 milliliters per mole, a 20% smaller volume. Where does the water go? It's a great question. I don't know. And in fact, nobody really knows, which is pretty cool. But the exact structure and what's going on in the fluids, though that too is starting to be molecularly modeled. But we can measure it, and we can measure it fairly easy. We actually measure the refractive index and calculate molar volumes based on that. And I won't go too much into that. I do want to talk about how we measure the refractive index. The data I'm showing today was taken using what's called a handheld refractometer. These are the ones on top. You actually use your eye to look at a sample that's on this glass prism here, put down the flap, and then you read the refractive index. I'm excited to say that with the help of the Sac City support of the Sacramento City Chemistry Department, we now have digital refractometers where we place a sample of about 1 milliliter in this little sample well. We use our phones and they communicate so that we can read the value for the refractive index on the phone. This data, by the way, was taken using the handheld refractometer. It's it was last spring, I believe. And the measurements are relatively simple. You take some 2-propanol, you measure its mass, you take some water, you mix them in. If you know the masses, you can know the moles. And if you know the moles, you can know the mole fraction. Mole fraction is just moles of 2-propanol divided by total moles of 2-propanol in water. These are all beginning Chem 400 style calculations. And we're measuring the refractive index and plotting it against these mole fractions. So these are actually very simple experiments to do. And the green dots are our data. The yellow dots are literature data. And the dashed line is what's an ideal solution. And you can see that we can simply measure quite a non-ideal solution that is also in line or similar to literature data. And I've got the literature data reference down here at the bottom. Well, there's a bunch of calculations that we go over once you're in the research class that allow you to turn refractive indices and calculate partial molar volumes. I've got the references that told me how to do it, or taught me how to do it. But this is a graph of partial molar volume of 2-propanol in green, partial molar volume of water in yellow, and the filled circles are our data, and the dashed lines are the literature data. And what you can see is we're not 100% correct, but we're catching trends and we're looking for improvements in the spring that might make these two closer. And, but it's exciting that we've been able to calculate these partial molar volumes. Well, a new aspect of this project in the spring is that we will actually be measuring the density of these non-ideal binary solutions. We will use an easy DENS instrument connected to a smartphone. And what it actually does is it vibrates the solution and can tell the density. And you can imagine, and I still have some work to do to understand this myself, but if you have a mass and you vibrate it, the vibration frequency depends on what the mass is. And of course, the mass depends on what the density is. Density equals mass over volume. Here's a little animation of a tube. This tube has fluid flowing through it, and you can see there's some sort of oscillation. Make the fluid heavier, the oscillations change. So the oscillation frequency is responsive to the mass and the density of the solution. And so that's one of the things we're going to be adding to the research class this spring. Just to remind you, the Chem 484, 405, 406, that's morning and afternoon at the SCC Davis Center. If you've had 400 and 401, please do consider signing up for the morning class, which will be the collaboration with Osvaldo Gutierrez at UCLA and molecular modeling. The afternoon class will be wet chemistry measurements to understand non-ideal solutions. And here is my website, WJW Miller, that's WJW, I know the J is a little hard to see, .com, and I keep a running total of all my past projects. In summary, research is a great way to get hands-on problem-solving experience. It's a great way to really enjoy science because you're actually doing it. Sac City is blessed with a number of classes, and research experiences are great resume items for transfer, for being a chemistry technician, for medical schools, and our acknowledgements. We have significant support from a variety of sources, which we're very thankful for. I've got this. I'm going to go ahead and post this into the chat again. This is the link to the Google Sheet to sign in for attendance in case your professor told you that you get extra credit for at least partially for attending this section. Thank you, and Tiny and I would be happy to take any questions you have. Thank you for your attention. I'll stop sharing for just a minute. Does anybody have any questions? I'm sharing the Google form if you want to sign in. I'll go ahead and go back to our presentation.
It's really exciting research in the new project, Bill. There we go. There's a question. Do you have to pay any money to apply or to participate in the REUs?
Good question. So you don't pay money, they pay you. That $5,000 to $8,000. I'm not sure, Maddie, if you were here. When I was mentioning it, but they pay you. The REUs are competitive, and they realize that they are having you do this research when you could be working a job or doing something else. And so Maddie, Maddie's a former student of mine and hopefully a future student. We'll talk about REUs, and you can email me and look around for an REU to do that you're interested in. We can talk about that. But yes, they pay you not only to go and do the research, but also usually to travel to wherever the location is. I do see one of my students asking, because my students have to turn in a one-page report about what they learned. And you can email that to me, my student. I won't out them.
It's a good idea.
Can I ask you a question, Tanya?
Yeah.
For your cannabis, so what kind of tests do you have students currently doing? Like for what kind of, I mean, do you have students looking for terpenes, looking for pesticides, looking for all these?
Yeah. Yeah. So this semester, of course, CBD, and then there's different forms of THC, even though it's a high amount of CBD in the plant. So the plants, when they produce them, you actually I grew my own plants, and the plants are just very high in CBD, low in THC, but you can still detect it with the instrumentation we have. But also, I test for pesticides this semester and heavy metals. So I have a student looking for chromium, using the AA, and then also some various pesticides. So we have standards for both of those.
Very cool.
Yeah, it's actually very, very, and then having the new LCMS come, that separation method's really good.
I see a
Okay.
couple other questions. One was just to me, it says, is there any way we can get a copy of the PowerPoint slides? Um, I'm happy to share mine. I don't know about Tanya, if you're happy.
Oh yeah, that's fine.
So email me and I can give you a copy of the slides. I just posted my email in the chat. Um, and again, if you go, so I don't think this latest stuff is up on my wjwmiller.com website, but it will be soon. And if you just go to that website, you'll see a bunch of information, certainly about the non-ideal solutions one. Since the project with molecular modeling, I only talked to Osvaldo. What did I talk to him Monday?
Oh
No,
my God.
Last Monday. So I've known about this for a week and a half now.
No, it's
Uh,
amazing. Yeah,
uh,
I really like that project a lot. I used to synthesize organometallic catalyst for my master's degree.
and
Iron too, a little bit, yeah. So it's very interesting work.
well, future collaboration then, Tanya.
Yeah, yeah. And for students, I'm an organometallic chemist, so that's like right up my alley.
I should say I am not an organometallic chemist
Now
at
you
all.
are, you're going to be learning all about it.
I'm going to be learning all about it.
Yeah.
Um,
When would
so
you?
I have a question. When would we need to reach out to you guys by if we're interested? So if so these classes you can register for them right now, I know from mine, meaning they're open, um, and but please do reach out
Yeah,
to
reach out, yeah.
us.
And for me, I'm only taking a few students for 44 because I have my other chem tech classes as well. So mine, I'm only accepting like 2 more students. But I'll put my email if anyone's interested in the chat.
And can I just say that Tanya's classes, so Tanya teaches not only the research class, but also an instrumentation class. And both are really good to get you qualified and real life skills that come in handy. You'll never know, or maybe you will, but sometimes you never know when a skill is going to come in handy. But understanding instrumentation is super important.
And just being comfortable around the lab. If you decide to go to grad school someday, if you want a job, yeah, you just really become comfortable working in the lab too. And you know what? It's fun. I think it's so much fun. I know Dr. Miller knows it's fun too. We really like this is like a passion.
Yes, we both love this. These are passion projects for both of us. I see a question. How are you qualified for REU? Is there a certain amount of time that is required in order to qualify for it? Uh, so technically, no. So let's say this. So we have placed students at REUs before, but they have typically been students who have had research experience before in programs just like these. So that helps. GPA helps. And then personal relationships that we are working on forming. And so just to let you know, so we're not 100% yet, but Osvaldo has offered, he said he's going to try and take 1 or 2 students for the summer down at UCLA from the hopefully the spring class. Again, the thing's so new. I didn't want to mention it during the regular program because until I'm sure of something, I don't like to mention it. But we are in, I would say, negotiations, or he's working to make that happen.
That's exciting.
Osvaldo is a super down-to-earth guy. I like him a lot. If any of my, so, you know, anyway, so I can't say enough about him. Let me see. Here's a comment that I think was to me, but it says, thank you, especially enjoyed the part about the CBD, the separation and quantifying of matter as well. So that's all Tanya there. Um, yes, so another comment, you're going to look over everything and reach out ASAP. Please do, to one or both of us. That's what this is all about. We'll take another minute. So last chance for questions. If not, shall we wrap it up, Tanya?
Yeah, and I just want to reiterate again, if you're interested, please reach out. I'm happy to answer any questions. And again, I'm on the main campus, so that's where all of our instruments are. So if you're interested, please just reach out. And thank you for coming.
And I'll just add, this spring is my last planned time to do undergraduate research at the Davis Center. After that, I'm planning for fall 25 and moving back to the main campus. And
Yay.
yes, I know everybody likes to plan ahead. So do I. So does Tanya,
Mhm.
of course. So anyway, if you're interested in starting in the Davis Center, do it in the spring. That's the one time left to do it. All right, everybody. Thank you all for coming. And I hope to see you sometime in the future. Thank you, Tanya, for helping do this with me.
Of course. I mean, amazing. I loved your presentation. I need to step up my game. That was so good.
Oh my God, Tanya, you should have seen me reading over Osvaldo's information. You would have crushed it because it's all organometallic chemistry, right?
Oh,
I'm
but I
like,
love that stuff. I'm like, oh my gosh, you're doing that stuff. It's so cool. Yeah.
I'm
You
looking at this stuff going, all right. So
explained it really well.
you can see these. I was like, I'm gonna key in on these energy numbers because this phosphophenol thing, I'm like, oh my
Oh, it's
goodness.
so cool. And go to the other slide really quick. The one where you have like the so you have
Oh,
the
this thing?
enantiomers. Yeah, so part of my research too is I was trying to make a chiral catalyst, and we bought a column specifically, just a chiral column, and that was my first experience with doing that at Fresno State before I went to UC Davis. So it was really cool. And it's so fun. It's all schlenk work. It was all schlenk work.
I know
And
you've told me what flank work
I'm
is.
trying to buy a schlenk line right now.
I don't even really know what that is, but
Yeah, I will show you because I'm so excited about it.
that's so cool. Look at this. They're applying potentials to it.
That is
Uh,
cool.
anyway, thanks, Tanya. I'll see you around. Okay. I'll see you tomorrow. You're coming to lunch, right?
I'm not sure yet. I thought I would be able
What?
to go. I know I have I told you I have my class, and then I forgot I have my final evaluation meeting in between, and then I have my next class. So I'm trying to decide, and I have a student coming to make up an exam during that time too. So I'm a little worried about the time.
I will
But
bring
I
you
want to
lunch if
go, but
I know. I will
yeah.
bring you lunch if you don't come, but hopefully you can make it.
I know, I'm gonna try. I'm gonna manage it because it's our last class. And because we had that one Friday, we did interviews and everything. I want them to be able to wrap up their project tomorrow.
Totally get it.
Yeah. All right.
Well,
Well,
I
it's
will see
always
you.
great, but
Yep,
I
I
will
will see you
see you
tomorrow for
regardless,
sure.
I hope.
Yep.
Okay. Okay,
Take it.
bye, everybody.
Take care. Bye, everybody. I'm gonna end the meeting, I think, if I can figure that out.